on data cascades in high-stakes AI, done in collaboration with my colleagues Shivani Kapania, Hannah Heifel, Diana Akrong, Praveen Paritosh, and Laura Arroyo, all at Google Research. Data is the critical technical infrastructure necessary to build AI systems. It can determine performance, fairness, robustness, safety, and scalability of AI systems. Paradoxically, for AI researchers and developers, data work is often the least glamorized and incentivized aspect, viewed as operational relative to the lionized work of building models. Data is often viewed as a databases, legal, or licensing issue, but we believe that HCI has an important role to play in elevating data work as a first-class citizen of AI systems. In this paper, we examine data quality practices and challenges among AI practitioners working in high-stakes domains where there are safety impacts on living beings, such as maternal health, road safety, and climate change. Our primary contribution is to present empirical evidence and conceptualization around data cascades in AI systems. Our method involves semi-structured interviews with 53 AI practitioners working in high-stakes domains, including researchers, engineers, and data scientists based out of India, USA, and Eastern and Western African countries. We observe and define data cascades as compounding events causing negative downstream effects from data issues that result in technical debt over time. In our study, 92% of our participants reported experiencing at least one cascade, and 45% reported experiencing two or more data cascades. Data cascades are complex, long-term, occur frequently and persistently in our study. They're opaque in their diagnosis and manifestation. They're triggered when conventional AI practices are applied in high-stakes domains like viewing data as operations, moving fast to proof of concept, or hacking model performance without consideration for data quality, or undervaluing domain expertise and data labor. Data cascades have negative impacts on the AI development and deployment processes, leading to harm to beneficiary communities, burnout of relationships, discarding entire data sets, and performing costly iterations. Cascades are often avoidable with early interventions and stepwise operations, though. We observe 4 types of data cascades, but I'll discuss 2 for brevity. High-stakes AI systems are typically brittle, closely interacting with previously undigitized environments like air quality sensing, ocean sensing, or ultrasound scanning, leading to several reasons for a model to break, like limited training data, complex underlying phenomena, or volatile domains. Now, data cascades here can appear in the form of hardware, environmental, or human knowledge drifts. As an example, even the slightest movement of a camera due to environmental conditions can result in a model failure in detecting traffic patterns. Artifacts like fingerprints, shadows, dust on the lens, improper lighting, and pen markings were reported to affect predictions. A conventional AI practice of training on pristine data but deployed in the messy real world appeared to trigger these cascades. Another type of cascade was triggered when AI practitioners were responsible for data sense making in contexts in which they did not have domain expertise, like diagnosing fractured bones, identifying poaching locations, determining congenital conditions for preterm babies. All depend on expertise in biological sciences, social sciences, and community context. A conventional AI practice of overt reliance on technical expertise and unsubstantiated assumptions of data reliability appeared to set these off. So data cascades point to the contours of a larger problem of residual conventions and perceptions in AI ML drawn from the worlds of big data, of abundant digital resources, of model valorization, of moving fast to proof of concept, and viewing data as grunt work in AI and ML. We need to move towards a proactive focus on the practices, politics, and values of humans in the data pipeline. We need to move from goodness of fit to goodness of data, from doing more to doing better with data. We need more structural incentives to reward and recognize data work in conference tracks, in organizational glue work, in greater collaboration between data collectors and ML developers. Data ethics and practical data work oversight boards like IRB and ethics standards should be a part of AI education and praxis. Finally, we need greater data equity in the global south.